Okay, in this video, I thought about explaining a simple PID controller. So here I am in Matlab. So what I can do is I can open is Simulink model, right? I'm going to create a new Simulink model. So I will be trying to explain what a PID controller is based on how I see it. This might not be the perfect explanation, but anyway, on Simulink under the new tab, I will create a blank model. So this might take a little while to load everything up, and once it is loaded, we will be adding all the blocks. So Simulink is like a visual programming tool that allows us to like uh, use block diagrams to design the flow of the inputs to the outputs. It makes it very easy for us to develop systems. So this is the Simulink window, and one of the very important components under Simulink will be this library browser. So a library browser is the place where you can get all the components. These are just devices that you can use to simulate. So under this library browser, one thing that you find very important will be the commonly used blocks. There's something like that. So we need to find that, and we will be using that. So you go to Simulink, you click on this drop down, and on that you will see this one, commonly used blocks. So here we have different blocks that we can use. So let's see what happens. So you have the scope. Scope basically means it is like an output device. It's basically like an oscilloscope that allows you to visualize the signals. And constant is like a constant signal. You have marks, demarks, integrators, differentiators, all these things you have that you can utilize to build a system. Okay, let's see what we can do out of these blocks. So let's drag the constant block first. Okay, once you drag that, it will be coming to our workspace like this. And to modify any parameter for this particular block, you can double click it and you can set the value and the other attributes, right? Don't worry too much. Let's keep it as a 1, and also let's visualize this signal. And to visualize the signal, you can use the scope. So I'm currently under the commonly used blocks inside Simulink, and you can connect this one to this one like this, and you can set the simulation time. So I'm simulating for 10 seconds. If I click run, uh, it will compile and do everything and show you the result. So you can double click this one, you can double click on the scope, and should be able to see the result. Okay, so if it is not visible, you can try to click on this one. So it's simulated for 10 seconds. You can see that if I try to zoom in this area, there's something near the one. Okay, and as it is a constant, it just looks like this. Okay, it's just a constant one. So that's how we use the constant block. So it's just a constant value. Okay, that's how a constant is like visualized, but it doesn't say much. So let's try to develop something more interesting, right? So you have this constant and this scope, right? So what else can we do? So you can go to these sources. Sources are like generators for signals. Okay, sources. So under sources also you find a lot of interesting tools that you can utilize. So here I can use the step input. Step input is like a signal. So you can connect this step input to the scope, and if I can modify here. So step time, when it steps initial value will be 0 and final value will be 1, and it will be, the signal will be 1 1 after a second. So let me click on this one, and you can see what happened, right? Something like this happens. Okay, I don't know why I see markers here. So you can like change how all this looks. You can like add add the legend, do all sort of things like that. You can basically change the view. Okay, you can do all that from this icon. Mm, and let me try to add the legend. So you can see that here you have this step. Okay, style. So visual marker, you can set it to none if you like, and apply an OK, so that you can see a clean signal. Let me try to add this one again and see what happens. Okay, to the constant block, and let me rerun this. Okay, so let's try. So again it's at 1, so it doesn't give a constant signal like the step function. Also, like we might be able to do some more interesting stuff using this one. So let me click on this one, and you can even run the simulation from here, so you can see what's going on. But you may need to like resize and do certain changes to visualize the signal better. All right, so now you had this two signals. It's very hard for us to like always change the signal by like drawing this wire from this block to the other block. So let's try to add a switch, right? The manual switch, we can add a manual switch. Okay, manual switch allows us to like change the signals by clicking on it. In order to add a manual switch, you can like search the manual switch block here, or else you can click somewhere on the workspace and start typing. And I will type manual switch. Okay, here is the one. So you can get this switch. Okay, and I can now rewire this one like this. You can have one here and one here like this. Okay, now let me show you what happens. So you can run this one. Right now it's connected to one, so if you open the scope, it looks like this. For some interesting reason now we are able to see the line. That's what I usually expect it to do, but for some reason it did not show up in the first place. So anyway, it's better that it is now working. So you can click on this style, and you can like what if I, okay, let me put this to none and apply. That's good. Now I will double click on this one, and I still have the scope here. Can I pin this one? Okay, let me pin this one by using my pin tool. And if I, okay, I can run it from here, and you can see the step. Is there something called auto or automatically scale axis limits? That's what I need, right? Okay, let me flip the switch again and run it. Yeah, it's on 1. If I run it now, I get the step. So in this way you can like easily flip between signals, right? So you can use the manual switch to do that. So it's pretty powerful. Now let's try to do something interesting. Okay, so here under the commonly used blocks, we explored some possibilities, right? So let's explore more so that we can build a PID controller. So to make this a little bit interesting, so under sources here you can see other sources of signals that we can use, like the pulse generator, the ramp function, and one thing that can be interesting is this sine wave. Okay, this is the sine wave. So can we like so this is, let's remove this one, and instead of that one, let's put this sine wave like this, and let's click on run. Okay, so now you can see the sine wave, and if I run it now, you can see the step function. So in this way, like we are able to switch between the two signals and see the output on the screen. Alright. Also, one more thing that you can do is like you can change the amplitude. If you want some other value, you can put it to like 10. Also, for the step function, step time, final value. This step happens after 1 second. So if you need to change that, let's say 5. After 5 seconds, the step function will be occurring. So you can even set the final value to, let's say, 25. Apply and OK. Let's run this one and see what happens. So you might need to rescale everything up. I believe I set everything to like auto scale. Zoom in, zoom out, axis scale, automatic. Yeah, it should automatically scale the axis. I don't know. Okay. Anyway, now the step function occurs at the time 5. Let me switch this one, and you can see the new modified sine wave here, right? So now the amplitude is 10. Now we will be looking at developing the PID controller. So you can add a transfer function block, just write tr and this will come up. So this is a transfer function. Transfer function basically takes an input and does something in the middle to give you an output. Let's wire the scope to the transfer function block so that we can see the output like this, right? So for the input, you can give anything. So right now we are feeding the sinusoidal input to the transfer function. So it takes the input, does something, and gives you an output. Let's run this and see what happens. So okay, this is what happened after like just passing the sine wave through the transfer function. To visualize this in a better way, let's also add add the sine wave mm, to the scope, right? Now the scope has two inputs. One is the sine wave which is coming directly from this block, and another one is the sine wave passing through the transfer function and the generated output. Let's run these two together and resize. Can you see the yellow one is the sine wave, which is the original function, and the transfer function does something, changes some things, and you get the output from the transfer function block. So the transfer function block has some things, some parameters that we can change to manipulate the signal. So it's like some transformation that is happening to change the input to the output, right? I don't want to go in detail regarding this transfer function block. Anyway, you see that some transformation is happening, right? So it might be better to remove this one and make sure that this is removed, and we actually get the original wave from here. So in that way I can like get both from the same output from the switch, right? So now we have the step function, but the transfer function does something like this, right? It curves the input to the output. Pretty interesting stuff. Let's run it again so you will get the results that you saw earlier again, right? So now you know what the transfer function does, right? It basically does something to the input to generate an output. It's like a black box here for now. Anyway, so you have all that, right? You have all that. That's good. So I want to explain to you a little bit about the difference between the input and the output. That can be interesting, right? So you 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 know that yellow signal represents the input and the blue represents the output. And also, if we subtract the two signals, that means you subtract the input output minus the input, right? Output minus the input, and you will get the difference. This difference is termed as the error. Okay, so you, in order for you to subtract two signals, you can use the addition block, right? So you can write add and get this, right? Okay, so what do we need to subtract? So you don't, we just want to add it, right? You need to subtract it. So you double click on this block and change one plus sign to a negative so that you can subtract. So you need to get the output first. So you get the output from here, and also you need the input, right? So input is available here, and this will be your third signal that I'm going to feed to the scope. So this third signal will be the output minus the input. Let's run this. Okay, so now you should be able to, right? You should be able to visualize that. So uh, this is what is happening. So 10, let's take somewhere here. It's like 10 minus 6. 10 minus 6. No, output will be the blue one. Sorry, output will be 6. 6 minus 10 is will be minus 4, right? So somewhere here. So this is the error. So we have an error, right? So can you see like the difference between these two signals are denoted by the signal coming out of this addition block where it subtracts. Okay, so you can also flip signs if you like and see this. Let's put minus and plus and see what happens. So now you should see the gap, right? Okay, let's run it. So you can like flip the difference. Anyway, let me put this one back. Should be plus and minus and apply, and okay, let's run this one. Okay, so hope you understood the difference between the output and the input, and right now we have the three plots, right? So let's do some interesting stuff and see what we can achieve with the PID controller. Okay, now let's try to add the PID controller and see what we can achieve. PID controller is a controller that is usually used to minimize the error. Suppose you have some error between the output and the input. PID controller tries to minimize the error. So right now the error is denoted by this red line, right? So we will use a controller to minimize the error. So let me move this one a bit up, and I try to move this node over here. Yeah, and try to move this one here so that it looks a little nice. Okay, everything looks good, right? Okay, let's add it like this. Right, so everything is looking good. So we need to add the controller. So let me like simplify this thing for you. Like let's add the PID block, PID controller. Okay, you add that block, right? Take some time. Okay, now we have a PID controller block here. Okay, so where should we add this PID controller block? That's the real question, right? Usually the PID block has to come before our system, right? So what is our system? Our system is this one, right? This is our system that transform the input to the output, right? So this is our input, right? Let's say this is our input. So earlier our system is like this, right? So you have the input, you have you have a system, and finally you will get the output from the system, right? So you can double click on this one, and yeah, so anyway you can go to properties, and you can block. I can't remember how to change the number of inputs. Anyway, delete, yeah, you can delete it. Okay, okay, let's add this one. So this is the system that we have. This is the normal system. So you can add the PID control, right? So PID controller is added before the system, so it should look like this. Anyway, let's try to run this one. Okay, let's double click on this one. Where's that scope? Scope, this one, right? Okay, it's right behind this one. So let's put this on the top and this on the bottom. And let me also try to resize this one. So our purpose is to like minimize the error, right? So let's also put this one here and rerun it. So our purpose is to like minimize the error. Right now our error is denoted by this red signal. So we are trying to minimize the error. So for the PID controller to work, we need the error. So let's get the error. Let's get the error. How can we get the error? So we actually feed the error to the PID controller, right? It's not just the signal that we need. We need the error term. So that's what we are going to do. So you have the input as well as you need the error, right? So to get the error, you have to get it from the output, right? Like this. All right. So now let's see what happens. Okay. Now also let's also visualize the input on the same scope. So how can we do that? You can connect the second port of this block like this, and let's run this again. Okay, so now can you see what happens? So transfer function, right? Transfer function uh, is denoted uh, by the transfer function output is denoted by this yellow line here. So what is the final value? Final value is 25. Okay, so it's almost identical to the top, right? So right now we can also visualize the error if we want to. So let's do that as well. So you can add one more signal here to this scope. uh, we can get it from here, right? That is the error difference between the output and the input. Let's try to run this. Okay, so can you see now it tries to me like the error term goes down after some time, right? Error term goes down after some time. So that's what the PID controller is doing. So yeah, actually like I subtracted it the wrong way according to this one. Anyway, let's flip this one. So let's try to see whether the PID controller is doing something, plus, minus and plus, to be exactly the same as the one on the bottom. Okay, now it looks similar now. So can you see that right now? Let's try to put them onto the same scale. At 8, it's almost, look, it's similar, right? So actually like we need to do certain things about the gains to make this work better. So that is called PID tuning. So you can click on the PID block and let's make this. It has three constants that you can change, P, I and D. Let's make this let's 10 and apply and OK. So this is without the PID controller. This is with the PID controller. Let's run this. Okay, now we have some interesting result. Can you see now the error term uh, reduces quickly, but the final output doesn't reach the 25. That's why you still have an error propagating, but it's more responsive. It like the signal, the output converges much fast. So you can play with these values. Let's add the derivative term. Let's say let's put like 2 here, apply and OK, and run this one. Okay, still doesn't make that much of an improvement, but definitely it did some change. You can play with these values and try to minimize the error. So integral term, let's put it like 2, apply and OK. Okay, it looks like the error term is like reducing a bit. Yeah, so you can like change. Let me put this one like 4, and this one has 3, and this one maybe 3. Apply. Okay. Again, you can play with all these values. Okay. So the transfer function output is looking like this now. Anyway, the error became 0 after some time. But it looks weird. So hmm, let's put this one as 2, and this one let's keep it at 10. Apply, and okay, you can play with the values. I'm just trying to explain you what is happening here. So let's increase the item a little bit and see. Let's put 5. Okay. uh, so looks like doesn't make any change. So derivative term 6. Apply. Okay. Okay. I think uh in this way, like you can like play with the values and see what's going to happen. So this is how we can add a PID control. So you can like play with different signals if you like. So let's add the sine wave and see what happens. So let's put the sine wave and let's run this one. Let me also switch this one here so that we have the exact same thing. Okay. Okay. Now can you see it works much better for the sine wave? Earlier, like the difference between the output, which is denoted by this blue, and the input, which is denoted by the yellow, was different, right? It has some difference, and you can see that the error is much. You can see the error, right? After adding the PID controller, can you see the error is very small? So we reduce the error or the difference between the desired output that we expect. I mean, in this case, the desired output that we expect is the same as the input. So when we have this desired output from the system, then the error will be minimal. That's why we have a minimal error after adding the PID control. You can do a lot of things by changing so many parameters. Nah, this is the basic explanation about PID controllers. So thank you very much for watching. Hope to see you in another video. Have a nice day.